Hello everyone, in this video tutorial, we will see how we can use YOLO-NAS for personal protective equipment detection. We will train the YOLO-NAS model on personal protective equipment dataset, and we will then test the fine-tuned YOLO-NAS model on multiple images and videos. So let's get started. I have already prepared a Google Colab notebook for this personal protective equipment detection project, which you can see in front of your screen. We have divided this complete project into multiple steps. We will start with installing the packages, then we will import the required libraries, then we will train or fine-tune the YOLO-NAS model on personal protective equipment dataset, and then we will test our fine-tuned model on multiple images and videos. So let's start with installing the packages. So here are the 4 packages which I am installing. I am installing the super gradients package. So to do object detection using YOLO-NAS, we require the super gradients package. Plus you can see as well, I am installing the RoboFlow package because we are downloading or exporting the dataset from RoboFlow into the Google Colab notebook. Along with this, I require the IMUtils and PyTube package as well. So let's first install these packages. So I will just run this cell and install all these 4 packages. The package installation will take 5 to 10 minutes. So let's wait for the packages to get installed and then we will go ahead. So now you can see that the packages are installed. So now in the next step, before importing the required libraries, I will just click on runtime and restart the runtime. Please remember, or please make sure to restart the runtime. If you don't restart the runtime and start importing the other required libraries, you will get the error. So now here I am just importing the trainer library so that I can instantiate the trainer and the data loaders library to load the data. Plus, as we are just fine-tune the YOLO-NAS model on personal protective equipment dataset. So our YOLO-NAS model has been trained on the COCO dataset and we are just fine-tuning the YOLO-NAS model on the personal protective equipment dataset. So I am just importing these required libraries as well. And to clear the output, I am from ipython.display. I am importing clear output library. Plus I am importing pp YOLO e loss. You can choose other loss as well. Plus the evaluation matrix I am choosing is mean average precision with IOU 0.5. And so I will just import all these required libraries. So here you can see that I am just importing all the required libraries over here. So from the super gradients library, I am just importing models. So I can just instantiate the model. So after this, I will just start the training as well. So we are done with step 1 and step 2. The step 1 was to install the packages and the step 2 was to import all the required libraries. And we are done with the step 1 and step 2. So good. So now in the next step, what I will do is this is the file section. So in this file section, I will create a directory by the name checkpoints. So I will just create a directory by the name checkpoints, and inside that directory, I will have the folder by the name ppe YOLO-NAS run. So this is the name of the directory which I will create in the file section. The name of the directory is checkpoints. And inside this directory, I will have a folder by the name ppe YOLO-NAS run. And in this folder, I will save the best model weights, the model weights on which the model give us the best mean average precision. Plus, I will also save the average model weights plus the model weights on the last epoch. So these 3 model weights will be saved in this ppe YOLO-NAS run folder. You can change the name of the directory as well. Plus, you can also change the name of this folder as well. Plus, also along with this, in this folder, we will save the log files over here as well. So now in this video tutorial or in this project, I have just prepared this dataset for this project. So you can see that our dataset consists of 3,290 images. You can see over here, we have 7 different classes in our dataset. And if I just go to the health check, so you can see over here, our dataset is only 3 classes are underrepresented while all the other classes are balanced. So this is good as well. And after preparing the dataset over here, so I have just done the pre-processing as our YOLO-NAS model has been pre-trained on the COCO dataset, and the COCO dataset default size is 6 or the YOLO-NAS model trained on the COCO dataset, and the image size or involved there is 640 cross 640. So it's always better to fine tune or pre-train the YOLO-NAS model considering the same size on which it is or in which the YOLO-NAS model is pre-trained. So YOLO-NAS model has been pre-trained on the image size of 640 cross 640. So we are just fine tuning the YOLO-NAS model on the personal protective equipment dataset considering the same image size of 640 cross 640. Plus, I'm just modifying the name of the classes. Previously, I've just written 0, 11, 3, 4, 6, 9. So after I'm just modifying it to protective helmet, 0 class belongs I'm just overriding the names to protective helmet, and where we have the 11, I'm just overwriting to shield, and 3 to safety vest, 4 to dust mask, 6 to eye wear, 8 to glove, and 9 to protective boot. So just changing the name of the classes. And so if you don't have enough images in your training data, you can do augmentation to increase the size of your training data set. But you can see over here, I have in my data set, I have 3,290 images. So I don't need to do augmentation. So if you don't have enough images in the training data, you can use augmentation to increase the size of the training data. But in my training data set, I already have 2,300 images. So that's enough. Plus in my validation set, I have 652 images. Plus in my testing set, I have 327 images. So now if I just click on generate, it will just prepare the data set into the required format. So I will export the data set from RoboFlow into the Google Colab notebook. So if you just click over here, I have already generated the data set. And if I just click on export data set, so now over here, you can see that I will be able to export this dataset from RoboFlow into the Google Colab notebook. So I will just copy this code. So if you are using Jupyter Notebook or Google Colab notebook, so it's always better to just copy this code and just paste this code in any of your cell of the Jupyter Notebook or Google Colab notebook. But if you are using PyCharm ID, Spider ID, or any other ID, you can just copy this code and paste into the terminal. But if you are using Google Colab notebook and upon the Jupyter notebook or any other notebook, you can just copy this code and paste it into the cell. So I will just copy this from here and just coming back over here. So I will just paste this code over here. So now I'm just exporting the dataset from RoboFlow into this Google Colab notebook. Or you can say that I'm downloading the dataset from RoboFlow into the Google Colab notebook over here. So the dataset downloading will take around 1 to 2 minutes. It is a quick process. So it's first downloading the dataset in the zip format, but it will automatically unzip it. We don't need to unzip it manually. So now you can see that 100% complete. So if I just click over here, you can see that dataset is downloaded. We have the trained dataset, test dataset, and validation dataset. So if I just go over here, you can see that over here. So we take around 70% of the images in the training data. In computer vision, in normal practice, we take 70% of the images in the training data, 20% of the images in the validation data, and 10% of the images in the testing set. You can just rebalance this as well. But in usual practice, we take 70% of the images in the training data, 20% of the images in the validation data, and 10% of the images in the testing data set. So now you can see that we have a train, validation, and test folder. We have the images in the images folder, plus in the labels folder, we have the bounding box coordinates. So in the labels folder, for each image, we have the .txt file, which consists of bounding box coordinates. So this represents the class number, and these are the x1, y1 coordinates, and these are the x2, y2 coordinates of the bounding box. So now you can see that in the step number 5, I am just loading the dataset parameters into a dictionary, which you can see over here. I've just created a dictionary by the name dataset parameters. And in this dictionary, I am just defining the main directory of my dataset, which you can see over here. And then I'm just defining the train images directory, train labels directory, validation images directory, validation labels directory, test images directory, and test labels directory. And if I just click on the data.yml file, you can see over here, my dataset consists of 7 different classes. And I will just follow the same sequence which is written over here and just copy this from here and just add these classes names in the same sequence which is provided over here. So here you can see that the first one is dust mask, so I've added dust mask over here. The second one is eye wear, so I've added eye wear over here. The third one is glove, so I've added glove over here. The fourth one is protective boots, so I've added protective boots over here. The fifth one is protective helmet, so I've added protective helmet over here. The sixth one is safety vest, so I've added safety vest over here. The seventh one is shield, so I've added shield over here. So that's look pretty good. So now we have just defined our dataset directories, training, validation, and test directories over here as well. So now I will just pass these values of the dataset parameters into the dataset of a parameter argument over here. And here I'm just defining the batch size and the number of workers. So batch size means how many chunk of data will be passed into each iteration. Okay. So what does batch size mean? 16 means basically batch size is always in the ratio of or in the power of 2. So 2 power 2, 2 power 3, 2 power 8. So it will be 2, batch size value will be 4, 8, 16, 32. Okay. It's always in the power of 2. So our complete data set will be divided into 16 parts, and in each iteration we will pass data one by one. So if you just reduce the batch size, the training time will increase. So please make sure that data batch size should not be higher than 32, because it will be your notebook will crash simply. Okay, and your batch size should not be very low, like 4, because it will definitely increase the training time. Okay. So you should keep the batch size value from 8 or either 8 or 16. That is a good value. So I'm just inspecting the data set which I have defined earlier. So now I will just plot a batch of the training data over here. So I'm just plotting a batch of the training data over here. So see how my training data looks like. So you can see that we have helmet, protective helmets, vests, gloves over here. So this is just a plot of a batch of the training data. So I'm now so here I am just instantiating the model which you can see over here. So YOLO-NAS comes with 3 different models: YOLO-NAS small, YOLO-NAS medium, YOLO-NAS large. So YOLO-NAS small is the fastest, but it is less accurate, while YOLO-NAS large is the most accurate, but it is less fast. In this project, I will be using YOLO-NAS small model. So I already told you YOLO-NAS small model is the fastest, but it is less accurate, while YOLO-NAS large is the most accurate, but it is less fast. Okay, so you can see over here, we are just using YOLO-NAS small model, but super gradients of YOLO-NAS provide us YOLO-NAS medium and YOLO-NAS large model as well. So you can just use these models as well to fine tune your YOLO-NAS model or any custom data set. So now here you can see I'm just instantiating the model, and dataset parameter classes mean, if you just go over here in the dataset parameters, you can see over here dictionary. In this dictionary, I have defined 7 different classes over here. So if I just find the length of this, so it will turn out to be 7. Okay. So the length over here will be turn out to be 7, and our YOLO-NAS model has been pre-trained on the Coco dataset, and in this project, we are using YOLO-NAS small model. So I've just instantiating the model over here. So that's good. So now here you can see that I will now define the metrics and the training parameters. So before you start the training, there are 6 mandatory. These are the 6 mandatory arguments that you must define before starting the training. You can skip the other arguments by default, but these are the 6 mandatory arguments that you must define before you start the training process. So these arguments include maximum number of epochs. So the maximum number of epochs means how many epochs you want to train your data set, or how many epochs you want your model to be trained. And then we define the loss function. You can use pp YOLO-E loss or any other loss, but in the start, I have imported the pp YOLO-E loss for this project. Then you will define the optimizer. You can use Adam optimizer, STD, align optimizer, or RMS prop optimizer. It all depends on your choice. Then you will define train metrics list, validation metrics list, and the metrics to watch. In this project, I am using mean average precision with IOU 0.5 as the metrics to watch. So now here I'm just defining the training parameters, which you can see I've defined the optimizer as Adam and initialize the learning rate over here. Plus I have defined the loss as the pp YOLO-E loss. And here you can see I've defined the validation metrics list. And here I have also defined the training metrics list as well. And if you just go over here, I have defined the metrics to watch as mean average per year with IOU 0.5. So I have defined all the necessary metrics and the training parameters, which you can see over here. So now I have just downloaded some demo videos from online resources and just paste those videos into my drive. So I'm directly downloading those videos from the drive into the Google Colab notebook. So after I train my YOLO-NAS model on personal productive equipment dataset, I will be testing my model on these demo videos, which I'm downloading over here. So we have downloaded a demo video, we have instantiated the model. So now comes the big step. We have instantiated the trainer, we have defined the dataset parameters and the data loader. We have instantiated the YOLO model. So as I told you, I'm using YOLO-NAS model or YOLO-NAS small model. So I will be fine-tuning the YOLO-NAS small model on personal protective equipment dataset. And we have defined the training set parameters over here, which you can see. So now let's start the training, or let's fine-tune the YOLO-NAS small model on personal protective equipment dataset. So the training will take around 5 to 10, around 40 to 45 minutes. So I will just start the training, and when the training completes, I will be back and I will show you the results, and then we will complete the video. So let me just start the training and let's pause the video. So guys, we have trained the YOLO-NAS small model on personal protective equipment dataset, and we have got some very good results. So you can see over here, I have got a mean average precision with IOU 0.5 as 0.808, which is 80.8%. So we have got a mean average precision with IOU 0.5 as 0.808, which is 80.8%. So this is very good. Plus, after training the YOLO-NAS small model on personal protective equipment dataset, I have just downloaded the model weights and just added those weights onto my drive. So I'm directly downloading those weights from the drive into this Google Colab notebook. So here you can see that I will just download the best model weights from the drive, because after training, I just saved the weights into the drive. So if my runtime crashes, so I don't need to restart the training. I have downloaded the model weights and pasted into a drive. So if my runtime crashes, so I have added the weights onto my Google Drive. So I will directly download the weights from the drive into the Google Colab notebook. So you can see over here, I have downloaded the weights from the drive into the Google Colab notebook. So here I'm just defining the best train model over here. Okay, so you can see over here, I have just added, these are my best model weights. So I've just added the path over here, and I'm just defining the best train model over here. So now I will be evaluating the best train model on the test dataset images, and let's see what recall value, what mean average precision value, and what F1 score we got on the test dataset images. So this will take around few minutes before it is ready. So here you can see that we have evaluated the best train model on the test dataset images, and you can see that we are able to get 0.8076 mean average precision with IOU 0.5. So it is 80.76%, and we have got a good recall score, but F1 score as well. So the results are very satisfactory. So now I will just go over here in my validation dataset image, and I will just take a random image from here and just test our model or best train model weights on that image, and let's see what results do we get. So let me just add the path over here. Okay, so let's test our model on this random image of from the validation dataset. So you can see over here, we are able to detect the safety vest, plus we are also able to detect the protective helmet as well. So the results look impressive. So I will just go further ahead. So you can see that before training, I have downloaded 2 demo videos. So I will just copy the from here, and let's test our best train model on these videos. So here you can see that in the output video path, I have defined detection 1. So our output video will be saved by the name detections1.mp4. Okay. So you can just write any name over here. So whatever name you will write, your output video will be saved by that name. And as I'm using GPU, so I will be using CUDA, but if you don't have GPU available, you can use the CPU in your system, but the processing will be very slow. So now I am just doing detection on this demo video, which I have defined over here, and just saving the output video by the name, which I have defined over here, detections1.mp4. So let's do detection on this input provided video. So I'm using the best trained model weights to do detection on this input video. So the complete video is being divided into 310 frames, and we are doing detection on each of the frame one by one. So this might take few more seconds before it is ready. So you can see over here. So now it's ready. So I have just displayed the output video over here as well. So here you can see the output video. So basically, let me just download this video because here we have the small screen size. So we can't see the output very correctly. So let me just navigate my screen towards this output video. So you can see over here, we are able to detect the safety vest, protective helmet, protective boots. So the results look very impressive. You can see over here, we are able to detect the safety vest, protective helmets, and protective boots as well. And let's test on some other video as well. So here I'm just adding the weights or adding the video part of this video over here. And our output video will be saved by the name detections 2. You can change the name of the output video as well, whatever you want. And let's use the best model weight and let's do the detection on this input video, and our output video will be saved by the name detections2.mp4. So our complete video is divided into 267 frames, and we are doing detection on each of the frame one by one. So it's done. Okay, so it will be ready in few seconds over here. So this might take few more seconds before it is ready. So I have displayed the output video over here as well. So I will just download this video because if I just play over here, the screen size is small. We might not be able to see the output very clearly. So let me just download this output video and let me navigate my screen towards this output video. So guys, here you can see the output. You can see over here, we are able to detect a safety vest. We are able to detect a protective helmets. So the results seem very impressive overall. So I hope you have learned something from this video tutorial. That's all from this video tutorial. In the future video tutorials, we will come up with some more use cases of YOLO-NAS. So that's all from this video tutorial. See you all in the next video. Till then, bye-bye.